We might actually be live. It's been a minute, right? But we are broadcasting. I've got a bit of a new weird little software audio endeavor that I've been tinkering with lately. Thought I'd actually have something to maybe stream related to that today. So yeah, it looks like as per usual we are should be broadcasting on Diode Zone. Check all the technology. Yeah, so we've got Diode Zone, YouTube, and Twitch. And Tugo just walked in here. I wonder if he's going to settle down and pick a location for this stream. Oh, so I got kind of perversely curious about that voice that always shows up on TikTok. The text to speech that always sounds like it's trying to sell you something or present you with the latest clickbait headlines. I don't know if anybody is here yet, but gotta press ahead regardless. It's not like, I had a schedule for this today.
Modernism feds Americanized courtliness TL's monodic concomitantly deals plants, hayrides, invasions. Missioners locate spores while parasites standards intimate condoned Argentina crosshatch weakling sauced. Spoilers arbitration hoggishly hustling cordial Jasmine Christopher's parallels.
That's right. There's something like uniquely terrible about this.
Ray and Nagy's grapple Rousseau mustive ecoturists, leery triggering there. Shavit stammerers revolts blondus Seyfart's Clara's recruitment pluperfect and real lyricism Rigel much bakes. Medicare's discoverers of it interested. Modernism feds Americanized courtliness TL's monodic concomitantly deals plants, hayrides, invasions. Missioners locate spores while parasites standards intimate condoned Argentina crosshatch weakling sauced. Spoilers arbitration hoggishly hustling cordial Jasmine Christopher's parallels.
Oh, little squeaker. Hey, are you hungry? You just want to say hi?
Photosouth heats camps appendices, Ray and Nagy's grapple Rousseau mustive ecoturists, leery triggering there. Shavit stammerers revolts blondus Seyfart's Clara's recruitment pluperfect and real lyricism Rigel much bakes. Medicare's discoverers of it interested.
Oh gosh, is that still repeating?
Modernism feds Americanized courtliness TL's monodic concomitantly deals plants, hayrides, invasions.
So, Tuco's doing pretty well lately. Hey. Yeah? A little squeaker. You just want me to open the door? No? Dude, that's so weird. Oh, he wanted to sit in a seat. Hmm. Oh, honey. So yeah, that's the cat situation. His name's Tuco. Do you want to hang out, Tuco? Hmm. Honey. Do you want to play Bolt? I don't know if he wants that. I will actually talk about this project a little bit. I don't know if people even like the talking or the no talking, but I figure I'll have some of each. But when Tuco's sort of freshly wandered in and hasn't decided where to settle down yet, it's a little hard to concentrate on anything. I'm just glad he's doing so well, though. He had a bit of a health scare between the last stream and this stream, and that was part of why I was gone for a while. I was pretty worried about him. He wasn't eating enough for a while, but you can see he's much rounder now. He ended up having a bunch of teeth removed. And now he has a much better time eating without a massive dental infection. So yeah, he and I have been having a lot of good quality time. He's been finding lots of good warm places to hang out. Yeah, it was really sad how much pain he must have been in when he was having that tooth problem before me or any of the vets he had seen so far noticed what was going on. But yeah, he ended up getting surgery in December, and he recovered really well after that. He started trying some new foods, and he's always been a bit picky about food, but you know, now it's down to finding something that fits his preferences and his sort of fickle digestion, whereas before it was all that plus his mouth hurting all the time. There's a question about the coaster melt project and whether it's continuing or not. I haven't really had a reason to continue it, but then I didn't really have a reason to start it in the first place. So that's kind of where it's at. Like I could pick it up, but I don't really have any immediate plans to. I've heard from some people who have tried to replicate the effort that the particular Blu-ray drive that I used for the project is super hard to find now. So whereas I'm sure, oh, hey, Chuk. You gonna sit there? I think that's pretty clean. You're gonna be completely in the way. So yeah, I've heard that particular Blu-ray drive, for folks who aren't familiar, Coaster Melt is the name I gave to a project that I started a while ago. It was like the first couple of videos I posted on the YouTube channel. It was originally an effort to reverse engineer a Blu-ray drive to try and get it to do things other than just read or burn regular Blu-ray discs. I thought it would be cool to make sort of interesting optical diffraction patterns on discs that you could maybe use to do cheap patterned projectors for like graffiti or whatever. There's a lot of things that I thought it would be interesting for. You know, maybe you could use it as as sort of a kind of microscope to image the surface of objects, perhaps. But all of that relied on both understanding how this very complicated system works and developing firmware patches for it or alternative firmware. And so I got to some fun places. Like I got to understanding enough of the motor controller to send it some basic commands. And I started understanding a bit of the architecture, but it's still like a long way between what's there and something that would actually be useful. So it's an interesting project, but I think part of me, gosh, this angle is really awkward right now. Part of me was pretty maybe optimistic that I would find some folks on the internet to collaborate with the project on, and kind of by the time any of that had a chance to materialize, there were these issues in finding the actual drive. And it's not like there were that many people to begin with who are likely to want to do something so weird and specific and time consuming. But yeah, if you want to continue it, then you would either have to track down the same kind of drive or port the project to a different drive. You know, these are like lineages of controller firmwares and system on chips that are designed by companies and refined over the years. So you'd probably end up having to find something from the same product line but newer, and then see how much of the effort you could salvage and how much work you'd have to repeat. You could certainly go through the same first few steps to try to understand how the firmware is structured and how to insert your own code into a running system. Tuco will still... So, I think he does a lot less of the biting on stuff now that we have fewer disagreements about basic food and, like, dental issues. But, he will still occasionally bite wires, and especially when he's trying to get comfortable in my studio here, this is the most stressful place for a cat that likes to bite wires. Someone's asking if the Coaster Melt thing had any relation to LightScribe. LightScribe was much earlier. I mean, that was a consumer thing to print on the surface of disks, whereas I wanted to do something that was like an actual modification of the drive to try to print and or read much higher resolution patterns. So like LightScribe, it seems like it might be an interesting starting point to understand how that was implemented in the firmware, but it didn't seem like something I could use as like a direct basis for what I was interested in experimenting with. Oh, let's go. Yeah, so like a lot of folks who have asked about coaster melt want to reverse engineer the firmware so that they can do a specific kind of like backup and or piracy thing, which is certainly a reason that a lot of people reverse engineer these firmwares, but I'm not like super enthusiastic about doing that myself. Tuco is just gonna do his own thing for a minute, which maybe means I can do my own thing too. So yeah, I just got kind of morbidly fascinated with this TikTok voice. I did a little investigation to see just how it was implemented. I was curious to see if it was a client-side or server-side model, and it's entirely server-side. And in fact, it's a completely unlocked, completely simple API that you can just curl stuff at. So it's actually something that fits in a tweet. You can just dump some strings at this TikTok API and it will give you an MP3 file. So I started just feeding it random strings of words to get an idea of what that would sound like. I was more interested in like the sound of this for like audio or like music projects than using it for like normal text-to-speech purposes.
Turd preserves delivers peopling titled lassies, redepressors blockages, flogging prejudiced flank networks. Misapplication pommiest non-legal cryogenic conundrum provost edgings. Flux oil fields overpass.
Right, so that's the most annoying TikTok voice, the one that is very popular and also like the most kind of extreme clickbait headline voice. And you can kind of start to see how it's working there with just like the random words. It has some stage in the algorithm that picks a group of words to break into one utterance. So something that starts and ends with silence and is sort of formed as a thing that you think about saying and say like kind of in one batch. So it has one stage that breaks down the text into a bunch of utterances. And then it seems like independently those utterances get transformed into separate waveforms. So I imagine that those are done with separate systems, maybe separate machine learning systems, or maybe something handwritten that sits in front of their machine learning system. It goes back. So yeah, this was kind of surreal. I have a longer version of that too.
Smokiest underwhelmed medievalists in here spherically wheresoever penultimate inflamed. Pharynges recruituses, cabled newscast transmigriffy laundrymen augmentative censoring newspaper fuss budgets.
Sound like
Sandcastle intermixes, redactor parenthesizing coldly.
So, what's the next step? So I got some hints about different voices that existed. I only saw 6 of these voices in the actual TikTok app as I was experiencing it.
Shipmates resplendent shade swishers backseats eradicate
so it's got these, which are just given different like names and icons in the app. But
Metapia zombies coupling toglia tel renunciations vacuums clatter shoemaker
Australian English 1 and 2, UK English 1 and 2, or 1. US 2 is the annoying one. US 6 is like trying to be US 2's male counterpart, I guess. It's not quite as horrifying, but it's close.
Arrows, stoutly cones roans cleavages. Patricidal lion-hearted solemnities crack down couturiers tuberculin de viltries deep.
culinary ventricles issuance yodeler foraging tetrahedral. Mischief undecideds lissome grumblings glassed muggiest demarcation bullhead smirking eyeliners befallen. Arbitragers unstopped lampoons rotisseries engulfment assails aspirant breadth matron. Channeling heretics anarchists superciliously skirting reversibly distributor sowing electoral injunction.
Almost relaxing once it's become abstractified to no longer sound like
reboot administrates inertly skilled. Salvaged recollecting polluter spatial flossiest
these
clouts
things
imbibe
are
weathered
somewhat
parties
horrifying
verges
when used
purse
for their
jingled.
intended purpose,
Jawbreakers.
but could I find some interesting way to use them as like samples? So one thing that's interesting is that you can just get a fairly wide variety of different intonations and just like subtle variations in how it chooses to put stuff together based on something that seems pretty arbitrarily chosen. So I can just give it dictionary words and then end up with enough variety that if there's some feature, like say pitch detection that I want to run on it, some feature detection, that I can then find a wide variety of those features. So yeah, there were 6 of these normal voices in the app in my region. And then there are a couple of hidden ones. Also, this ghost face one seemed like it was like a promotional voice that was available.
Kicker shuttling
currently.
rock tentacles overstretched neat ranking charge refit undercut prices typically streaky. Mayflies, evens, frizzles, titillatingly prefabbed rennet. Homesickness, redcap, infarction,
I got a request to make it say reticulating splines. Yeah, we could do it. We could do it quick.
Benches. Shipmates resplendent sheet.
My terminal. Yeah, this is basically the script I had in the tweet.
Apologize, attendee luggage somberness, automobiles, shovels, hikers, derails, XXX, ye backstabbing restrengthened. Non-dramatic, sire-polished varsity attender, doggiest, hypertext things, suffragist blabs, reverberated mishearing. Staphylococcus crumplier, inventorying pollen, undelivered telfering nothings.
All right, you can see the utterances have this structure that just sort of keeps going up and down, like as much as your ears will tolerate. Just packing as much interest and making it as shiny as possible. It's an interesting way of speaking, right? That like extremely attention-grabbing kind of tabloid headline style. And this will just apply that style to anything. Actually, I made a little script to make this slightly easier.
Reticulating splines.
It broke up a little bit.
Reticulating splines.
My audio setup here is slightly overcomplicated, sorry. Yeah, so I started downloading a bunch of these. Playing with it a little bit in Python. I don't know where they got the samples for this, but I just noticed this on Twitter and it was kind of funny.
Not drinking too much. Regular exercise at the gym. 3 days a week. Getting on better with your associate employee contemporaries. At ease. Eating well. No more microwave dinners and saturated fats. A patient, better driver. A safer car. Baby smiling in back seat. Sleeping well. No bad dreams. No paranoia. Careful to all animals. Never washing spiders down the plug hole. Keep in contact with old friends. Enjoy a drink now and then. Will frequently check credit at Moral Bank. Hole in
I don't
wall.
have to listen to the whole thing. It's depressing, but you know, it's the thing you would do with that voice, right? Okay, Tuco is right in front of my monitor, sorry. Okay, I think that's all the Twitter. I don't necessarily need the Tuco grooming close-up, but I figure he'll be hanging out here for a minute. So distracting when I get echo of my own voice in the headphones. Okay, so yeah, the TikTok voice, getting a bunch of samples, pretty straightforward to get effectively a corpus of fairly creepy but uniform text. I ended up trying this technique that I'm about to go through on a few other material corpora, I guess. So there's also this thing called Mozilla Common Voice, which is an open data set intended for training machine learning speech recognition models. And it's a bunch of recordings of people speaking sample phrases. There are also some public domain audiobooks I found. I think the project was called Liberavox, so I ran some of those through here too for comparison. It's kind of interesting to see how those sound. It'd be interesting to look at how the real voices and this sort of extremely creepy TikTok voice are different. Okay, so I started trying to just play around with these samples. Let's see, I found this library, Librosa, that seemed pretty useful for this. Thought I had it ready to go in a window. Yeah, I just started searching around for, who's already implemented the sorts of audio processing algorithms that I might be interested in. And so Librosa has a bunch of cool things in it. It has a pretty overkill pitch detector I'm using right now. It's a pitch detector called Yin, and then there's a probabilistic model that helps it stay stable over time, called probabilistic Yin. And I think those two, especially together, are just a little heavyweight for this, but it's what I'm using right now, and I've managed to crunch through a bunch of data, so we can at least experiment with some of this. It's a pretty cozy little library. I say little, I'm sure it's enormous, but it'll have some basic things like FFTs and autocorrelations. It has units and other handy things. But yeah, this is the function that's basically doing all of the work in this first stage. Fundamental frequency estimation using probabilistic Yin. If you've ever tried to detect the pitch of some audio, it's not extremely straightforward, especially depending on what this audio is. So you might expect that you just, do an FFT and then look at the FFT. And very broadly, that's how most of these algorithms work. But there actually is a lot more to it, because the FFT is going to be messy, and the things that appear bright on the FFT aren't going to be stable or straightforward to identify, or always the best representative of the fundamental frequency. So what these are trying to do is not even necessarily look for like the loudest harmonic, but they're looking for the best estimate they can find of the period of the signal. So they're looking for overall, what is the sort of lowest frequency repetition it can find. And it's trying to estimate that in a way that works well for music and speech using a probabilistic model. And so I've been giving it mostly speech. Ah, JUCE is so fuzzy. This was something I posted on Twitter where I just tried mixing all the samples together. Kind of like a pressurized can of bees. We don't need to keep that. That was just funny. So I wrote this little offline tool to process all of that input audio in different size batches. I started out processing maybe like 10 clips each that were maybe 30 seconds long at a time. But the batches I've been working in now are more like 10,000 of those clips. So this is just something that runs for a long time and eventually gives me a data file that has a bunch of these numeric Python arrays in it, an NPZ file. And then I have other IPython notebooks here that will load that NPZ output and then visualize it in different ways. This was the first thing I started doing, which I haven't been maintaining, but I still have the old output from it. It just loaded those databases in and started to examine how they look if you sort them by pitch and start plotting like histograms that show you the frequency of, the frequency distribution of those fundamental frequency estimates in the input. So you can get a rough idea of the pitch range of the different voices and how they might combine together. So I plotted these a little weirdly. They're not in hertz, they're in mel units. Two different kinds of mel units. There's like a more widely used variety which are similar to hertz. So if you see it go up to 1,000 mels, it'll be about 1,000 hertz. This is a different version, which is the default in Librosa, but I didn't realize it was the less well-known version. And so that's why the scale is a little weird, but it's like intended to be a perceptually uniform frequency scale. So it's sort of logarithmic. You can see broadly that some of these perform a lot differently than others. Like a lot of them just seem like they just have a bell curve sitting somewhere. But because all these are on the same scale, if the magnitude is significantly different, that does actually impact like how many pitch features we identified. So like the Chewbacca voice, we actually identified way more features than average. I don't think I even played that one yet. There's a bunch of novelty voices, right? There's a bunch of Star Wars voices. The Chewbacca voice is very repetitive. It doesn't seem to have a whole lot of variety in it. So it has a lot of voiced sections with really strong pitches in it because of the sound, but it doesn't have a lot of variety. So when I include that in the model, it ends up getting used a lot and it just doesn't sound very interesting. Somebody is asking me if there's a paper that is about yin, and they have a link. I'm sure there is a paper. I don't have the link handy, but it would be in the documentation for Librosa. They have links to the academic papers that their code's based on. Oh gosh, somebody says that there's a Groot in addition to the other novelty voices, and this one has even less variety. Yeah, so I haven't even seen that one, but so I have databases from Chewbacca, but I haven't been using them super much. The ghost face voice sounds pretty interesting, but it actually, because it has that sort of very raspy, hissy kind of sound to it, the yin detector doesn't give it a high voiced probability very often, so I don't end up saving very much of it. So the magnitudes here are very small. Kind of sparse here on the Stormtrooper too, but like Stitch has a lot of voiced sections, a lot of variety. So you can kind of get a profile for these different inputs. And what do I do with this? I just sorted everything by pitch. I think I posted this one on the internet already. It's a little intense. Made some charts too, but it's more fun to just listen to the output. Okay, so then I've been trying to deal with a compacted version of this data from this point forward. So those NPZ files are pretty big. They've been ranging from, like a gigabyte to 20 gigabytes or so. Kind of inconvenient to process. I guess I'm doing this slightly out of order. I did start to synthesize more audio before I started trying to compact the database. So I'm trying to go through some steps that I did before this stream to kind of get back up to speed on how this project is going before I decided to try to stream what I've been doing so far. Okay, so we've got these large grain databases, the NPZ files. Take a look at some of those. So yeah, I've got some very small ones here that had just small data sets, but most of these I used 1,000 of the TikTok text-to-speech output files, and they're like a gigabyte. And then I've got these much longer runs where I use 10,000 of those files, and they're about 1.2 gigabytes or so. So it's, like, not going to break my disk, but they're very inconvenient to try to do real-time synthesis with. But I wanted to see how they sounded, so I tried to do some non-real-time synthesis with that. That's what this script ended up being for. So loaded all the voices, made a big table in memory, looked at the frequency ranges, and made some more sweeps.
Biomedical surgical deflection.
First color modifies
Randomization erratic mono
zusammenzulegen in abgesehen fehlender Selbstihren kann sehr gesehen zuzuhören.
Unhealthiness Avenges geriatric minimizes shunting positions, contaminates Jazz's largest supply cottages sardine.
The drone of the collective unconscious. Yeah, basically, I mean, it's like basically where I'm trying to go with this. Like, I want to see if I can turn the TikTok voice or possibly collections of speech in general into a kind of creepy live instrument that you can use in audio software. So a plugin that you could load into Ardour or Ableton or Reaper or whatever. And so part of that means having a database that isn't insanely large to work with. I'm trying to figure out how much of this I even have to load into memory, right? Like, do I want to have to load an entire copy of the sample data into memory? Like when you open the plugin, do I want to try to stream it from disk? My first inclination is to try to do something where, assuming you have it on an SSD and you are running on a pretty fast computer, that I do stream it from disk and decompress it from like FLAC into floating point buffers. But anyway, that's getting ahead of where we're at right now. So you can start to get a sense of the like two-dimensional field of sample data that we've got now. So we've got something you could visualize with a pitch axis and a grain selector axis. So when you sort all the grains, you get something that's binned by pitch, but then you have so many grains there that you can then choose within those bins. And so if you turn that axis vertically, you now have a two-dimensional thing. That's kind of where I'm trying to go. So this is like sweeping across one axis, and this is like sweeping across the other axis of that two-dimensional field.
Biomedical surgical deflection.
First randomization,
Erratic monodemonstrates
zusammenzulegen, abgesehen fehlender Selbstbestimmung, ihren Transfergesehen zuzuführen.
Unhealthiness of Avenges questing interrelate minimizes shunting positions. Wiretapping task is Jazz's largest verifying cottages sketch sardine.
There's a question about the languages. Yeah, there's definitely Japanese in there. There's some German. There's French. I put several languages. Spanish. Okay, so then I tried to do some MIDI synthesis. So this thing so far, I'm just giving it a list of frequencies and like where to put those grains. I'm wrapping that in something a little higher level that takes a MIDI file and then converts notes into repeating blocks of grains. That's pretty much it. And then I just give it a classic here. And then I started trying to play small parts of it. Try not to get feedback every time. Yeah, that was just the first 10 seconds, but let's try just playing everything. Okay, so that thing is interesting and weird, and it makes me want more, basically. Like, it's not very well mixed. It's got all sorts of stuff that I can't really hear, and it's super muddy all over, and it's got hard-coded parameters for these inputs on the synthesizer, the grain width and the grain interval, which would, of course, be interesting things to be experimenting with in real time. So this was like at the point where I decided it needed to be a real-time thing and not just something that I could have an IPython notebook crunch on for a while. I did still break this down into individual stem track sort of things to get an idea of a little bit more of what was going on, and we're not going to listen to all these, but I'm going to skip around a little bit. Okay, so this one is entertaining, but it's really slow to run. I was hoping I'd have like execution times here so I could remember how slow it was, but I'm sure I was waiting a while to get the output from this, and my database wasn't as big as it is now. So I started trying to build smaller databases using this tool. Well, what turned into this tool? So it starts with some set of input files. It's loading in just the index from those inputs, and then just visualizing the different spectra that we have. And then we're trying to combine them together, but then kind of truncate that. So we're throwing away extra grains in bins that have a lot of grains to begin with. And we're also throwing away bins that are just so empty that they will only have a couple of grains in them and they'll sound repetitive. So there are some parameters up here that really control this. Currently, this pitch resolution parameter doesn't really affect much because the pitch resolution is being controlled by the resolution we're running the detector at. So these bins will end up being much smaller than the detector's bins, which I think are set at like 5 cents right now, because algorithmic complexity is even worse if I try to bump that smaller. I mean, the effects are worse when I bump it smaller. So anyway, this is an arbitrary small pitch resolution, but then these control the sizes of the bins we end up with. And then for every grain that we decide to save, this is how much audio around that grain ends up getting saved. So you can imagine different ways that the grains might end up getting distributed throughout the original audio. Maybe you have some really sparse grains where you're just grabbing little bits here and there, and so you end up with these chunks of, I guess in this case it'd be 4 seconds of audio with the grain center right in the middle there, and you'd end up saving all of those. But if your original audio is denser, then you could end up having grains that overlap substantially, and so you only end up throwing away the audio that's more than 2 seconds away from the center of a grain. And that's what a lot of what this tool is doing. So this is not super fast, but I think I can run it on my entire data set in something like an hour right now, which is somewhat manageable. But it gives me all these smallish output files that I can then try to render in real time. And I tried making a Python tool to play these in real time, but Python is really not an ideal language for doing kind of really demanding granular synthesis. I tried somebody's Python-based sort of DSP framework, sort of a Python max MSP sort of thing. I think it was called PYO. It seemed promising. It didn't seem to like working with sample files as large as what I'm using though. And it seemed brittle enough that I didn't super feel like debugging it. So I wanted to use something a bit more robust as a sound tool. It seemed like I could do something with web audio, and that would probably work. But ultimately, I wanted something that I could use as a plugin with other audio software, so it seemed also worth kind of taking this project in a direction where I'd have to learn how to make an actual audio plugin. I was hoping there'd be something for Rust that would let me make cross-platform audio plugins, but really the framework that everyone's using for cross-platform audio plugins that are either open source or kind of indie proprietary these days seems to be JUCE. So that's why I'm starting out trying to write this in. So this produces a JSON file, which I hope to be able to just load into my JUCE-based real-time synthesizer. But I also wanted a version of that slower Python synthesizer that can just validate these compacted files. So this is really just a re-implementation of that full synth notebook, but using the compacted input files. So I had something pretty arbitrary loaded into this. What even was this? I think this was that LibreVox dataset here. These are public domain audiobooks.
Gains, then set at large shall be interdicted
to all eternity,
and ancient flame to reason without having to figure speak eternal pleasure also dominates from the cruelty that pursuing that
who go one or better than 100 spirits as those run to the mountain.
It's interesting, the difference in audio quality and speaker are much more noticeable in these. Maybe if I used a larger data set, they wouldn't be though, because this is ultimately a much smaller data set than the TikTok data sets. Terrible thing to do to someone's audiobook, right? Kind of interesting. I think it might be nice to try to make a version of that with a larger input corpus, but like right now this is a ½ gigabyte. This other one here I think was done with all the TikTok voices enabled. It's 1.8 gigs. Let's try loading this one. This one actually has progress bars. So this just has a couple 100 kilobytes of index data in JSON, which load really quick. The thing it's loading now are the actual FLAC file chunks. And that's just because this Python library I'm using can't seek in FLAC files. But generally seeking in FLAC files is a thing one can do. So I expect the C++ code to be able to just load these off of the compressed file as necessary. has some real outliers in the pitch detection at that end.
Incorrigibility counterpoint news airbell nominations anzulenken meistens
Utmost theory and bounce chase ultra realign gamma's hyperventilating non-participants sprays tiptoeing and most
Yeah, it's a bit of a whole process right now to make these compacted files. But here's one starting up with just the annoying voice, and the largest input I have for that. See, it's just by itself has a pretty wide range. Trims down to this nice rectangle. And then it's going to spend most of its time collecting this audio data. Actually, this isn't going to take that long. Is it going to process this one file in just a couple minutes? That would be cool. Anyway, so there's this pipeline. There are several of these output databases now to choose from. That one that we were just listening to is something like 1.8 gigs. And that had most of the TikTok voices in it and some other stuff. So that seems pretty similar to the output we were getting with the full synthesizer. So I was trying to figure out JUCE from there to get myself synthesizing something in real time. So how's this other project? Oh. Okay, I don't know what the Venn diagram intersection is of people who are interested in streams about weird audio phenomenon and people who are interested in C++, but that's what I've got on the table today. So yeah, C++. So JUCE is an interesting framework. I am certainly a newbie at it still. This is my first project trying to use it. It has a very interesting kind of modern C++, but also very non-STL feel to it, which is interesting. Like, it doesn't use much of the actual C++ standard library. They have a lot of their own containers and things, but they're also using kind of C++ 17 era features. It's kind of interesting. I wish the documentation was a bit more specific about thread safety in all circumstances, because coming from Rust, where things are a bit more like rigorous in the memory and concurrency safety department, it has me on edge a bit and fairly sure that I'm messing up a bunch of things. To go. Oh yeah, there's a comment. Gustinian, I think, says they were attempting to do a granular synth in fourth for an STM32 DSP and got sidetracked with FFT and SD card driver stuff. Yeah, that's relatable. I've certainly started projects where it's been like something that would be a relatively mainstream endeavor, like making a computer program that processes audio. And then I get really distracted by having to do it in like my specific way and doing all the low level stuff in some specific fashion. That's almost kind of why I wanted to do something with JUCE, like the urge to do the opposite of that a little bit and make something that is just sort of mundane and will run on anybody's laptop, basically. So it would be nice if this is something that ends up sounding interesting, that I want to like put out there as a open source plugin, that there would be an easy way to do that or whatever. So I've got a bunch of files here. Most of them are pretty small. Most of this is UI. When you start a new JUCE project for an audio plugin, it gives you an audio processor and an audio processor editor. And that's the sort of actual audio DSP engine, and then the kind of optional UI component that you can have 0 or more of. And it's got a lot of tools provided for kind of establishing a shared data model between these components. And there's a lot that you can kind of take or leave. Like there's an interface that your plugin has to adhere to, but then there are also a bunch of optional utilities that are provided in order to facilitate providing that interface. So like the audio processor, for example, needs to be able to save and load its state. So it's got get state information and save and set state information. But internally, actually, what that's doing is kind of delegating this to the state member, which is one of the many ways that JUCE provides to handle this. It's kind of a prepackaged way of handling state info that gives you most of what an audio plugin wants. It gives you a apparently thread-safe way of passing. I'm still a little shaky on understanding exactly what parts of this make it thread-safe, so I'm putting some asterisks here, but it seems to be intended to be thread-safe, and it seems to be intended to be a database of parameters that can be modified either by your UI or by the audio processor itself or by the plugin host, so the like audio workstation that you've loaded the plugin into. And this does most of the work. And it will do most of everything that you need to create parameters, as long as those parameters are numbers or like choices. So things like the grain width, that's just a parameter we can wire up to something in a DAW, and it'll be great. Input file is something that doesn't really fit in that mold. So one of the JUCE examples included some code like this that shows you how you can add some UI specific parameters to this looks a little weird, state.state, but this first state is actually that audio processor specific state tracking thing, the audio processor value tree state. But then a value tree is actually just a more general data structure within JUCE that is sort of it's sort of like you can think of an XML or JSON style like blob of variant data that you can nest. And in this case, you can also share it between different components, and you can attach callbacks to listen for changes. My understanding of the threading model here is that changes to the shared data end up getting serialized through a message loop that has its own locking. So there's a sort of single message thread that processes changes one at a time. But I'm new at this, and I may still have a hazy understanding of how that works. So if we were to start from the entry point here, so this all gets linked into a library. There are a few different ways that this gets built. It'll either get built as like a VST or audio unit plugin. JUCE also includes its own wrapper that will take that plugin and build it as a standalone application. So it'll include a little bit of UI for just wrapping your plugin in a regular window and letting you choose audio input and output devices. So this could either be called by an adapter that loads this into a DAW, or it could be called by an adapter that loads it into that standalone application. And then this one instance of the audio processor holds its own state and also provides these methods for processing audio in real time. So my understanding is that most of these methods generally would get called on like a UI thread, but process block gets called rapidly in real time on whatever audio engine thread this thing has access to. So depending on your operating system, this could be something with hard real-time priorities. So this gets interesting when you want to access shared data or when you want to access data that's on disk. So JUCE provides an interesting class that I might be about to deploy in this project that lets you take an audio source and buffer it using a separate thread that reads ahead into like a pool of shared memory blocks, and then you can read from that pool of buffered audio with like bounded latency, which helps you not stall the audio processor thread. So yeah, I don't know. This is a bunch of C++ that I'm kind of muddling through myself at this point, but it's starting to take some form. We've got this audio processor that does not actually process any audio yet, but I'm trying to come up with a model of the parameters at least. So I've got a bunch of these sort of regular JUCE audio parameters for the kind of mundane floating point things. I've got this UI state that I'm not really using yet that's mainly just copied from one of the examples. But then kind of using the same strategy as the UI state, which kind of goes inside this outer layer and accesses the value tree directly and adds something that it's going to manage at that slightly lower level without the benefit of the automatic connections to the plugin host. So that's going to include the URL, path name, whatever, of our grain data file. And because that's in the state tree, it'll get serialized and get state information, set state information, which will then end up saving it in your project file or wherever you're actually hosting the plugin, or in the preferences in the standalone host. There's another interesting feature in JUCE where these value tree data models, the actual values in them are stored in a kind of central pool of shared reference counted values. So it's actually easy and encouraged to set up these like local links to data that you are using, but it's actually resident in someone else's data structure. So for example, I've got this grain data member, which is, it's just an object that the audio processor owns that manages the grain data that I have loaded in memory, just to kind of divide the responsibilities a bit. And it's got a JUCE value in there, which has the file name of the source data. And I can just link that directly to the value in my state tree. And then when they change, I can get notified because they're actually the same underlying chunk of data. I think that works because any changes get serialized through the message thread. I get these listener callbacks on the message thread that say something changed. I still haven't decided if I maybe need like a background loading thread for any of the audio, but I think that after finding that that sort of buffering component that I mentioned earlier, I think I'm going to let that load all the heavyweight data, and it's probably fine for the message thread to load the JSON synchronously. So that's like the skeleton of the actual audio processor itself. Then most of this is just UI skeleton. So the audio processor editor, in this case, is just a UI component that has a few of these sub-panels within it. The same way JUCE will often give you an interface you have to satisfy, but then also leave it up to you how you can do that, and then offer a bunch of tools that might make it simpler. That's kind of how they do layout as well. When you have a UI component that's resized, it gets this callback, which then has to compute sizes for all the nested items within that UI. And you could just do that yourself. You could do rectangle arithmetic on them, but there's also this handy Flexbox CSS-inspired layout class. Even for something simple like this, where I could just be dividing it up into a few pieces, I actually swapped from calculating it myself to using their Flexbox class, because it seems like their Flexbox might also handle like keyboard tabbing order. I'm also not totally clear on that though. In any case, it's pretty simple and clean to set up, so it's useful for this class too. I had a basic UI concept for this where it would have these 4 sections, data, map, window, and parameters. Just have a little post-it note actually that I drew these out on. I figured that data panel at the top would have buttons and whatever, and information about the loaded files. That map would be a 2-dimensional map with like pitch on the x-axis and grain selector on the y-axis. Window would be the window function that you're using to shape the grains as you're playing them back. So these examples so far I've been using a Hamming window just because it was something that seemed like a sensible default, but I think I actually want a UI for adjusting the window shape. It'll probably have something to slide it forward and backward to bias it around audio that comes before or after the really tonal part of the grain, and then maybe a shape to sort of really emphasize the tonal part or not emphasize it quite so much. So making the window pointier or rounder. And so it seemed like having a way to visualize that would be useful. And then knobs, because everyone wants knobs. So concept. And so each of those separate pieces I'm just implementing using a subclass of the JUCE component, which is kind of the UI base class. There's helpfully a whole thing that just includes a drop down with recent files and a browse button and a file picker component and all that. So grab one of those for the file input, and then a label that shows the status of the data that we've loaded. There's nothing in map or window yet. And then in param panel, I built a pretty general purpose thing that just takes several of these settings that were defined in the data model and then generates UI for them in a loop like this, using the names that were defined in the data model. So I don't actually have to have anything specific to the individual components here, just a list of which ones I want and what order. Another Flexbox layout. And then I was working on this grain data model. I've just barely got it loading the grain data, but it doesn't do anything useful with it. So I've got this class that I'm definitely going to have to change. I just store all the grain data in these members. There's no concurrency in here yet. So ultimately I need a way for something to reload these grain data parameters from disk. So probably not load a lot of data, but load that whole JSON file into memory and parse it, store these arrays, and then generate a new audio format reader for the actual sample data. So that would involve opening the FLAC file, parsing the FLAC file's header, allocating a bunch of buffers, that kind of thing. So not reading a ton of data from disk, but doing a bunch of stuff that is too heavyweight to do in the audio thread. So I think what I want to do is have the message thread when we reload this grain data, load a new batch of all this stuff, and then like atomically swap it in a way that the message thread, or in a way that the audio thread can pick up. So something like that needs to be done, is not currently done. Someone suggests knobs plus a ribbon for scrubbing audio. So one thing that I'm doing differently compared to some grain synthesizers is I'm not scrubbing the audio in one dimension, I'm trying to scrub it in 2 dimensions. So that's what the map is for. That map is going to have a pitch axis and a grain selector axis. So this is basically a grain sorter. I take a bunch of audio, I identify strongly voiced sections of it that have like a strong pitch, and then I sort those by pitch into bins. And then within those pitch bins, I then have an additional axis that lets me choose like an offset within the audio. So that offset axis is a lot like how most grain synthesizers work, but I'm sort of putting another axis in front of that sorts by pitch. So instead of pitch bending the grains, I'm just like choosing grains that already have the right pitch. Different technique. All right, so let's run what we've got so far. Let's put that away. There are various ways to use JUCE, right? Like it's an open source library that you can do theoretically, basically whatever you want with. The easy way to use it is with this project manager they include called Producer. So that's what I've got here. It's a Producer project file. You can use their built-in editor or whatever, of course. It has built-in exporters that give you Visual Studio projects and whatever. On Linux, the simple thing to do is usually just to get a make file. So that will already exist over here. Anyway, I've already built this. Let's see if it needs rebuilding. I could have given that a -J, couldn't I? Tuco is always in the way, but it's all right. One thing I've done in the setup here is I actually have this on 2 monitors right now. There's like one that's a little bit more convenient for me because it's larger, but Tuco is blocking it. And then there's one that I can see the whole of, but is smaller, but is also something I can look directly at with the camera. So anyway, I've got a VST plugin, standalone. It would actually be nice if I could build LV2 plugins, the new Linux audio spec. I don't know if JUCE supports that yet. It seems like it should, but I can use VST3 in the hosts I care about, so I don't know that it matters. So build, we just run this thing. Oh, it's a little. So it actually already had my settings saved because it saves settings. The plugin host just does that automatically. I could clear this and kind of demo what it looks like blank. So default knobs, these are just rectangles because I don't actually have an implementation of those controls yet. Lets me open a grain file. Just pick one of these. And so this parses the JSON, tells me how big the file is, the different parameters here. And at this point, I have some data in memory that I might just be able to start reading samples from. I have those tables of pitches and bins and grains and frequencies, and I just have to actually write a mixer. There's a bunch of steps though. I think there's a bunch of UI missing, obviously. There's no audio processing code yet. I don't have like a real-time way to access the sample data right now. Right now I have something where if I just hacked some code onto the message thread, I could read individual samples, but I can't safely touch them on the audio thread yet. So that kind of works like you'd expect. Let's try this instead of plugin host. So I have Ardor and Bespoke here, which should both handle it. Oh, Tuco, you're so in the way. So I should be able to make a MIDI track. I guess I could have picked the instrument right there. Oh man, this monitor should probably be less tiny. I think I just need to rescan these. I think I already had it loaded into Bespoke. Maybe we can do that while Ardor is scanning. Yeah, this shows up with no fuss in Bespoke. And it gives us the UI here. Default parameters. We could open some grains. Works just as well as it did in the standalone. So my plan with this UI is that this top part would both display the structure of the data that you've loaded and also allow you to visualize what's being played and also allow you to play it manually. So x-axis would be pitch, y-axis would be the selector, the brightness or color or something. We'd have some color map that shows the actual offset in the original file represented by that grain. That'll show you the structure of like which voices are where or which parts of the original recording are where. I've got some plots like that over here. Oh, this is the most boring one, but that kind of plot, I had a more interesting one earlier, but I overrode it with a boring one. Yeah, I'd have to revert that from Git. So something like that. And I figure when you give this MIDI input, you could give it MIDI notes with pitch bend and give it arbitrary pitches and see those show up here. Maybe it also has an analog pitch input. Maybe you can also just play it by using like a touchscreen and using this as a XY pad. So I figure this will be like a visualization / performance surface. And then this will show you the shape of the playback window for the grains. And maybe you'll be able to manipulate this directly, or maybe it'll just be visualizing the shape that you've picked with the knobs down here, or some combination of the two. It's a question about why there's only 1080p quality. Yeah, sorry, I don't have a transcoder on Diode Zone. You can get a transcoder on YouTube. So the other interesting thing about this is that these parameters are linked to the plugin host automatically. So if I were to grab the grain width here, this will show up over here. This isn't going to produce any audio output, but normally you would hook this up to an audio output. You would maybe hook this up to a MIDI input. We could get a microphone input. And that would convert the microphone input from this mic I'm talking into to a control value. I can make it a little more sensitive. And then I can just connect this to anything like that. So now I've got a real-time-ish connection between the microphone and this grain width, which is a silly example, but you know, it's nice to know that the connection is working. I think similarly, you know, if I were to add another one here, if I grab this over here, I can watch it change on the plugin host. Anyway, so it's a plugin. It does very basic things that don't actually produce audio yet, and we can start adding to it. Oh yeah, if you're not familiar with this program, Bespoke Synth is pretty fun. I am also new at it, but it is quite fun, and I want to get better at it and maybe make some cool compositions with it. But this is the kind of environment that I imagine wanting to build a plugin for. Like, you know, if it complies with various audio plugin standards, you could use it in whatever, but this is probably the thing that I will personally want to try it with first. Let's see if Ardor has actually found it. There it is. Stale. There we go. Okay, so Ardor just had it hidden because I had recompiled it and it hadn't rescanned the new version of the file. Cool, so now I've got this instrument attached, and you know, it's still not going to actually get any audio, so I'm not going to bother hooking it up, but I can adjust I can double click on it and get the UI and adjust the same settings. UI is larger in Ardor. Is there a DPI difference? And so these are all going to have their own saved settings, which is probably what I want. These voices are all just named with a timestamp now, but I'll probably actually have files that have sensible names at some point. Cool, and this should be able to automate these parameters, record them and all that. Anyway. I think that's enough playing with the plugin that doesn't really do anything. So I think that ends the part of the stream where I'm just playing with the stuff that I already built. I think the rest of the stream might be trying to get a little further on this. Maybe get a better angle. Oh yeah, Tuco's got a good fluffy belly. He is much rounder than he was last time I streamed, which is a nice thing. Are you getting up now? Oh man. I don't know if I can handle the dark editor theme with the giant light right in my face. We need a cat break. I think actually the thing I was doing was reading JUCE code. Like that buffered audio reader thingy. Is this why some people stream with sunglasses on? I just thought it was to look cool or to be more anonymous. Buffering audio format reader. JUCE has been an interesting mixture at, as someone who's been like exposed to a wide variety of different C++ projects over the years. There's an interesting mixture here of like stuff that's actually really nice and stuff that is like nostalgic in kind of a bad way. Like one specific example, there's some documentation that makes a really big deal out of keeping the number of arithmetic operations in your sound code low and using as little multiplication as possible and that sort of thing, which is okay advice in some contexts, but then like on a desktop CPU is like really not one of the top couple things that are going to be contributing to performance, especially when you're in an environment that is more sensitive to things like latency and the amount of time you're waking up and the amount of memory that you're accessing on a regular basis and how well things fit into your CPU cache. But then there's also stuff that is refreshing. Like there's an easy way to group timers into batches that all wake up at the same time so that you don't have a lot of extra wake ups. Stuco no longer going to be in the way for just a minute. All right, there was one thing actually kind of worrying about this buffering audio format reader, but I don't know if it'll actually be a problem. So this data set that I've got is probably going to be on the order of a few billion samples. So this default has 32,000 samples per block. Maybe I have another like 32,000 or, low hundreds of thousands of blocks. That doesn't seem bad from like a memory management perspective. But then if you look at the implementation of this, so read samples, so it looks fine. Get block containing, oh, I'm sure there's a sensible implementation of that, right? Blah, 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 get block containing. Oh, it's a linear scan. So this is just going to get slower and slower the bigger our database is. It's maybe not a problem because like it's order of n, but the n here is not that big. It's just something that could have easily been order of log n instead of order of n, so it's a little frustrating. So I don't know if this is going to work, but this seems like a great starting point because it's very close to what we want. You can see this uses kind of a similar concurrency strategy where we do a pretty big heavyweight change by rebuilding the entire data structure and then atomically swapping in a new version of that data structure. See, that's also going to be, when you look at the whole loading process, that's sort of a order of n squared thing, because now you're rebuilding this block list in its entirety for each block. It's not going to be great. We might end up having to make a new version of this, but starting point. So this entire thing should be part of the group of numbers that we're swapping in. Part of why it works really well in that class, in their buffering audio format reader, they never have to give out pointers to any of this internal data. So when you swap out the old version, you can be sure that that data is immediately no longer in use and you can free it. And that works because this interface is so simple. We're just reading audio samples and that's it. Yeah, maybe that's actually a good model to emulate. Can we have... to go back? So there could be various ways this data has to be used once it's loaded. I don't know, two that are obvious to me though are that we need to actually synthesize audio and we need to draw that grain map in the UI. Don't do these things, Tuco. Drawing the grain map in the UI might even be the kind of thing that we do. Well, let's see, what is that? The core of that is making a bitmap from those tables that we loaded from JSON. So we don't actually need any of the audio sample data. We just need those JSON arrays. That could even be something that we pre-generate an image for when we load the JSON, but there's no reason to it. It would be easy to calculate that image at whatever resolution you want it at paint time. You just need access to I think you could just have mutex access to those arrays. Like, I think we can just hold a mutex for the duration of that paint. Duke's been so cuddly lately. It's been really nice the number of times that I notice him just cuddled up next to me in bed or whatever. Finding a nice warm spot. Click. So, thinking about how to make some of this stuff a little more firm. These members in the public interface, the two values, I think that's probably fine. The source is the value that we end up linking to the file name. And so we are listening directly to changes in that to do the actual loading. And then status is linked in a similar way back to the label in the UI that shows the results of loading. So that seems like an okay way to just have a human readable I don't know, like if you think of that the same way as the map, like there's a rendering process where you take the internal state of the grain database and turn it into a string or turn it into an image. I think the difference there is that I do actually have a good reason not to store the image, which is that I'd rather make it at the specific resolution that it needs to be drawn at. And then the string has this additional constraint of also being used for things like error messages when loading fails. Just throw all this into a structure. Look up how JUCE's mutexes work. I could actually open the JUCE documentation proper instead of just looking at their source code. My computer just crashed. Oh, Tuco just laid on my USB selector. Tuco, you're changing my input channel. Tuco. You just started purring super loud. Oh. They do use standards atomic in JUCE. That's nice at least. I think I want this to have a read entry point that is similar to a regular JUCE audio reader, but clearly I'll need some grain related inputs in here too. Why is that an int and this a float? It is a float. Why are they using an int type for that even though it is actually a float? I assume this is designed such that it lets the backend supply either floats or ints, and they're just taking advantage of the fact that they're the same size. Use this floating point data. Okay, so I guess the buffer just doesn't have to care. The type that it chose was totally arbitrary. It just needs something that is floating point / integer sized. I guess I'm probably only going to worry about reading floating point samples at this point. My data file is going to have integer samples, but I think I'm going to be pretty quickly multiplying them by a floating point gain factor. So at this interface, it's probably already going to be float. Another decision is, am I going to worry about reading full grains or partial grains, or do I care? I guess if I make it the caller's responsibility to do, I'm wondering like who does the amplitude normalization. The synthesizer that I wrote in Python just calculates the RMS like average volume of the grain and then normalizes them all so they have the same volume, which is kind of heavyweight. And the reason it's not straightforward to just pre-calculate those is that the amplitude of the grain depends on the window shape that you're using. So if you change the window shape, the amount of energy that you're actually getting from that grain changes. You could have some data structure that gives you the amount of energy over time. That's basically an audio waveform. But I'm sure you could accelerate that somehow. I don't know that you need to, though. Wondering if this state should actually be a separate, like externally visible type. Because maybe you want to have a way for the audio thread to like check out a version of the grain data state. And then once you have that, you've got like, do I want to make a whole copy of the table? I think it's fine for the audio thread to hold this mutex for the entire length of time it's running. This should be a very sparsely contended mutex. I kind of want to assume that this data is mostly owned by that audio processing thread, because I don't want to be copying these arrays a lot. I just want it to be able to access these, like take a mutex, pop in and access them, and then go away. But you know, I need some strategy for how to deal with the concurrent access when I have another thread in this reload function. So if that thread does the reloading, comes up with a brand new state object, and then briefly holds the lock just to swap in the new state. Assuming the locks don't have a lot of overhead for uncontended cases, which should be fine if we're using like modern locks like futexes, then that seems fine. I don't know if that state needs to be public, but it should maybe be shared between this and a class that is public. Yeah, maybe there's another nested class or struct in here. I'm thinking about a word like lease or loan or checkout or something, but I don't specifically like any of those. Tuku is so fluffy. I might change my mind about these names, but I'm thinking this has an accessor class. This is going to be very similar to having a bunch of separate like getter functions to access these, except that I want to not be acquiring and releasing the mutex so often. I want to just grab the lock once and then have access to this stuff for the duration of one audio processing invocation, like one audio frame. I'm so used to the lock class taking a template parameter with the type of mutex it applies to, but that's not how JUCE does it. What name do they use for that? They're calling both the RAII object and the mutex itself a lock. This is confusing. I'm just going to call this mutex. Oops. Okay, so I think the idea is the audio thread would create an accessor, use it for a while, and then destroy it. while the accessor is created, it'll end up postponing the final stage of any reload that the UI thread tries to do. How does JUCE feel about constness? Can I do anything with a const audio format reader? I can get its name. It is really tempting just to make the state public and then just give a reference to it. I'm not sure there's a reason to actually hide this behind anything at this point. I mean, there's the usual advantage of having a little bit of a layer that you can adapt later. You know, if you want to change the format, you can do that without having to modify the code that's actually assembling the audio. This would be a reasonable place, like accessors that make it easy to do something sensible with this data. I also don't want to be declaring everything in the header here. I'm going to let Clang format actually prettify this code. That almost looks like what I want. Just need to add a few more public numbers to this accessor. These are, it's tempting to make these inline. I'm wondering like whose job it is to do the addressing here. Gosh, you know, I think it does 0 of the addressing. I think it's most unconfusing if this actually just reads using the same signature as the regular JUCE audio format reader and passes that through. What does that return? Okay, so same signature there. We can omit the... Should we? Let's leave these. Guess we're kind of using this naming scheme. When I redraw that diagram on the UI, is that really going to be fighting with my audio thread? It is, right? Unless I have a different locking strategy or another copy of that data. Oh, thanks for the shout out in chat. I'm glad somebody found my RFID reader from ages ago useful. Oh, what does JUCE's multiple reader lock look like? Right, because if I'm worried about contention between the UI thread reading this data to redraw the diagram and the audio thread reading the data, like there would be contention there. Ooh, there's some kind of weird the hazards of having a microscope running. I don't know if I want to show you. I don't know if I picked it up or not. Bug diversion. Anyway, I was thinking about the contention. it's hard to share this audio format reader, right? Because if, say, I had multiple threads that were each trying to read different parts of the audio file, I guess it's got its own lock, so maybe that's fine. There's an internal lock that I think would allow that just fine. Yeah, maybe I just switch this to a multiple reader mutex and I don't have to worry about this problem that I just realized. Read, write, lock. All right, writers will block until all readers have released it, which I think is fine in this case. And it's recursive. Yeah, let's use JUCE as a read-write lock for this. So this way I can use the accessor from the audio thread, but also from other threads. I'm layering mutexes now, right? This is one of those things where if it's okay to nest mutexes only if you do them in the same order each time. If you have two pieces of code that both need two locks, but you acquire them in different orders, they can deadlock against each other. But in this case, I have a lock. I have just a regular mutex inside the audio format reader, which is always nested inside the read-write lock for this accessor. And so the UI code should just be able to connect this and then call these functions repeatedly with very little overhead. I think I like these accessors better than exposing the state, but only slightly. I don't know. Let's try this out. I think Clang format is going to put those on one line because they're so short. That's fine. Get to decide how I want to handle out of range inputs, right? I think generally for this type of code, it makes more sense to kind of convert out of range inputs to the nearest in range thing and then proceed. Alright, there's stuff like this, which I think we could use, or the exact same one that's in the standard library, pretty much. Oh, there's a 4-element min, 3-element min. That's kind of interesting. This is convenient. Let's use that. I was thinking about whether to include stuff like the file names in there. I think I want to try to keep this interface kind of sparse though. Be kind of cool if I could just return a range here, right? Instead of having to redo that first calculation twice. Does JUCE have a range type? I'm pretty sure it does. Pretty normal half open range. Let's use this. That's better. Oh. Oh, to go switch my USB channel again. Maybe I should unplug that remote. I guess I don't really need those headphones from not playing audio. Tuco is so in the way sometimes. Hey, round boy. Purr, purr, purr. Oh, I love how warm and fluffy Tuco is now that he's less tiny. Is he trying to bite my screen? Oh man, this screen is too small. Tuco heard grain and thought it was the tasty kind, right? Yeah, no, I was curious if anybody had done like a plugin that does grain sorting for audio. And I'm sure they have. It seems like a relatively obvious thing. It's just, it also might be the sort of thing that has only relatively recently become practical to do at this particular scale. So maybe it's not something that you find a ton of, but in any case, if you try to search for grain sorting, you would just find heavy machinery for sorting like wheat and chaff. Oh, honey. To go. I'm probably over worrying about what happens when these arrays are not the lengths that we expect they are. I think I might just depending on how we're feeling about error handling, there's an assertion I could put in here, because there should always be one more entry in the bin X array than bin F0. Bin F0 is the center frequencies of all the bins. bin X is the grains within those bins, but it's actually encoded such that it's the endpoints, not the actual bins themselves. There's one more boundary between bins than there are actual bins. I hate to go. We like fence post errors in software, right? It's where there's always confusion between whether you're talking about the posts or the wires. You can be off by one. Anyway, I'm going to program defensively here and have it calculate the minimum. Okay, so that should at least be using a consistent assumed length for everything. Good reason to have an accessors if you need to standardize edge cases. Okay, I was putting off writing this search here. So the actual operation I want here is a binary search, and then comparing which of the two nearest elements is actually closest. Let's see which library we're using has a binary search in it, because I assume somebody does. I mean, STL definitely has a binary search. I haven't seen like abstract algorithms in JUCE. Does it have a sorting algorithm? This might be the sort of thing they just use from the STL. I haven't been clear on like whether JUCE has specific reasons for using its own containers other than perhaps history. Like a lot of C++ code bases have their own containers instead of using the STL containers, just because for the longest time the STL containers were not really stable. And of course, like now they're ubiquitous, but for a long time when you used C++, you had to kind of pick and choose which features very carefully if you wanted to have any kind of cross-platform compatibility. And so a lot of people did C++ without STL for that reason. How do these sorts work, for example? Let's just look at the source code to that. I already knew where that was, but maybe I'll just grab. There's a sorted set. It's like I could definitely have written a binary search in the time it takes to find a binary search, but sometimes the point of programming is to find the binary search. I mean, so they're definitely using STL for sorting here. Yeah, I'm just gonna assume I can use STL searching templates. This is not quite what I want. All right, so I think in C++ binary search just gives me a yes or no. I could do two separate searches and get the lower and upper bound. I don't know if I can get them both in one operation. I mean, they're always going to be right next to each other, right? So I think you just get the lower bound, I guess, and then look next to it. Right, I think so. Lower bound, it's not less than, so greater than or equal, or whatever else. Dan. I think if we get lower bound and then lower bound -1 and then see which one's closer. Oh, what is the iterator type? Hmm. Am I gonna do pointer arithmetic here? I think if I was using the STL containers, they would have a nice way of getting from an iterator to an index. I mean, I think in either case, I can just subtract it. Like in regular C, that's pointer arithmetic, but I think if I was doing that with STL iterators, that would also give me the difference between them. Could use standard distance. I don't know if standard distance in this case is going to be like a loop or a subtraction. I think we just want to do the subtraction. This code has some slightly weird edge cases in it, right? Like, you have to think about what happens at the left and right edges of the table. In particular, if we're asking for a bin that's past the left end of the table, so the frequency is lower than anything we actually have, we want to return 0. We don't want to return -1, which is what would happen if we returned bin 0. But in this case, we're only returning bin 0 if this is actually less than, not less than, or equal. I think that works. Obviously, if this was real software, we'd want unit tests for this, but I'm still kind of just messing around. Just format that. All right. State is in the outer class. I want ref. Sure. What? Oh, begin. Let's start. Okay, I think that's mostly it on the accessor side. And the writer is going to need a new strategy. I guess Clang format is not actually deterministic, like it won't like reassemble lines, but it will break lines. I think I might make it Reload's responsibility to do this check so that it only has to get the lock in that place. Like, actually, I think I want a read lock that I then upgrade to a write lock. Just wondering if there was a special facility for upgrading a read to a write lock, or if I should just grab both. Looks like I grabbed both. I guess it does make sense to have value changed, grab its own read lock, and then reload grabs its own write lock. I do actually want to delay taking the write lock until the very end, right? I don't need the lock to update the status. It's a normal cat sound, not an abnormal cat sound. Okay, so making a brand new state here. This should construct it properly, and it'll have some nice empty arrays and default values for everything. Okay, so we'll still set the status last. Oh. Sort of. Really seems like I could ask the state to describe itself here, right? Yeah. Oh. I have no X display here. Let's do a fresh build, and if it still crashes, I'll debug this. Tuco's not back. I've seen JUCE crash in a very similar way when I just didn't have a X window connection, so it failed trying to create the GUI, but it might be something totally different. Assertion failure. JUCE displays 366. Control P. It really seems like JUCE doesn't like my monitor layout now. It's the same monitor layout I had when I was running it earlier, I think. Let's get a fresh. I had my monitors configured in a slightly weird way, so I wouldn't be surprised if that was it, but it also might be something totally different. Still 6 volts. Okay, is this the new changes I added? Because I didn't really touch anything UI related there, did I? Stash that. Oh, that comes up. Okay, how did I break the display code somehow? Hey, to go. You want the door open? I thought he wanted to look outside, then he immediately retreats. It is kind of cold. Okay, let's simplify this change a little bit. I was gonna throw that in there so that... Oh. Sorry, wrong monitor. Throw that in there so that load doesn't actually do anything. Oh. Did I break? Oh man, I don't know how much stomach folks have for C++ programming today, and I should take a break at some point, but it seems bad to leave it right when I break it. I should at least fix whatever I just broke. Oh, do I get a different seg file now? Oh, I don't have a initial value for that state pointer. Why am I even getting this far? Is that just a dangling pointer at this point? I thought that I would at least get a null initializer, but maybe we're not doing that. Yeah, let's just make sure that this is actually a valid understanding of what's going on, but then I think this just needs an initializer. Tuco's back there. I mean, it does look like a null unique pointer. I don't know why it's failing in exactly the way that we're seeing it fail. It's fine. So I wanted what's that? Oh, hey, Tuco. Loud boy. Oh, hey, Tuco. I don't know how we got that display assert out of that particular failure. So I was following a null pointer to a string and doing a comparison on it, which I would have expected either to just be dereferencing data at null or just dereferencing data very close, like within a page of null, which should have the same effect, or calling a null function pointer using a null vtable. I don't know how quite we got from that point to that point. It's interesting. Failed to load JSON data. Is that real? Tuco, what are you doing? Hey. Oh, are we using the wrong file name as input, maybe? I mean, I think I do actually want to use the copy of it, but that should be the same. Oh, you know what? That's what was going on. Source file up here is a string. There is a variant of JSON parse that takes a string and just parses a string as JSON. I actually wanted the variant that takes JSON, or that takes a JUCE file, and new state source file is a JUCE file. Like this assignment is actually creating a JUCE file object, so that's why that was happening. Not the crash, but the JSON error just now. That's better. So we've got sample rate, 0 bins. That's not right. Oh, I did a careless search and replace. That should fix it. Oh, it's way over there. Why did it start way over there? I wouldn't be surprised if there was just separately some esoteric multi-monitor issue in JUCE that I'm hitting, but I don't think that's really fundamental to anything that's going on, at least. Anyway, that looks plausible. 399 bins, 944 grains. Bigger one. Even bigger one. All right. So these will be easier to tell apart once you can actually play the audio from them and visualize the map. So the plan is once you pick one of these files, the map of the available grains will show up here, and we'll start streaming them in from disk on demand and buffering them in RAM. So the UI looks basically the same as it was before. The change under the hood that I just made was that now we have a plausibly thread-safe way of storing the data that the synthesizer needs. So I have grain data, which keeps track of the entire database and can be swapped at any point. Internally, it has the grain data state, which is the piece of it that I can swap around. There's the grain data accessor, which will temporarily take a read lock and let me get values from the database as I need them. And then internally, there's a write lock that gets used when I load things from disk. So that's going to be the best stopping point I find on this stream. Let's get this checked in. I know someone's going to ask me if this is on GitHub. I don't know if it will be. It's not yet. Chico, don't scratch that. Gosh. Oh, Took. Should we just hang out with him for a minute? Oops. Well, thanks for hanging out today. Sorry I ended up going so long between streams. I try to have that not be a thing. Seems like I can stream as long as I have a project and some minimal amount of mental and physical health, and, you know, for me and my cat. Oh, he's purring pretty well. We get some purrs. Oh. Gosh. Round. Tuco is so much bigger than he was last year. I mentioned this earlier in the stream, but Tuco had a bit of a health scare earlier. I was worried that he might not be with us for too much longer, but then it turns out that this bump on his face that seemed to be interfering with his eating wasn't actually cancer. It was big dental infection, so I'm sure it was really painful for him, but it was at least something that we could deal with. So he had some major dental surgery in December, and he's been doing so much better since then. Also, I know generally hardware projects are a lot more interesting than software projects. I keep finding myself stuck in these binds where, like, I know hardware is more interesting, but then software is much more accessible for people because it doesn't require huge amounts of objects and everything that goes with that. So I was going to try to do a bit of a fix-up stream on my old Pinebook laptop, because it seemed like that would be maybe a plausible 64-bit ARM development platform kind of thing for hacking around on Linux and Android and whatever. That was one of the reasons I looked at the TikTok voice, is I wanted to set up a debug environment for Android apps. And TikTok is one of those apps that I had made cursory attempts to try to load in a debugger before, but I'd run into problems. And I've still got the Pinebook on the table under here. Don't quite know what to do with it because it's a little bit broken. The plastic shell is in kind of bad shape, but it still otherwise works. It's just also not a very capable machine in general. It's mostly limited by the 2 gigs of RAM. Tuco, what are you doing? Oh, that is a touchscreen. Tuco, oh. Tuco was gonna add somebody to my friends list on Twitch. Sorry. He didn't cause any damage. It's not a touchscreen, at least. Oh, that's a good question. There's a question about whether I could give Tuco some kind of tactile audio interface and let him make music. Maybe. I mean, I don't know how Tuco feels about music. Sometimes he seems into sounds when I'm playing things. He certainly likes standing on buttons. He's a really chill kitty. I mean, he's also very intense, but that's kind of the nature of him. He will just cuddle and relax with the intensity of the sun. But then if you're also not paying attention to him just the way he wants you to, he'll yell at you constantly. Making me nervous by trying to bite all these objects I have on the desk. No, no. Hey, no, don't be biting that. Ow! No. I don't know if he wants this. I don't think that's a good cat toy, Tuco. It's metal covered in rubber. Aw. Yeah, Tuco does seem to want his own objects to interact with on the desk. Yeah, when I had the Pine Book on this Surface, I guess last week working on it, he would climb on top of it and it would freak me out because I don't think that touchscreen is, or it's not a touchscreen, it's just an LCD and I don't think it's very strong. You want this? You want me to attach this? Emily says laptops are irresistible to cats. Yeah, I guess that means that the Pine Book, at least in some way, qualifies as a laptop. When I'm trying to browse the web on it, it seems a little dubious. Well, thanks so much for tuning in, everyone. I'll try to do this actually frequently. I know I've said that before, but Tuco's in better shape now, and I'm in better shape, and my house is in better shape. Maybe I can actually make this stick. I'm in no hurry to cut short this particular little Tuco cuddle, though. Yeah, it's nice to see a bunch of familiar faces, and I shouldn't have been away for so long. It was a combination of a bunch of things. I think the most immediate thing that happened, I guess, is a combination of a lull in the project that I was doing and Tuco's health problems. So I was much more concerned about Tuco than anything else, and I still had that half disassembled voting machine on this desk for a long time. I only put it back together kind of recently. I was just distracted by Tuco stuff. And then when Tuco was doing better, I started having more of a problem with depression myself, because I think at that point it kind of reset my priorities a little bit and caused me to realize that nothing else is really as important as just hanging out with family, and Tuco's my family right now. So I kind of had to rediscover some foundational stuff to just feel okay day to day. And things changed a bit around here. Rearranged the house a bunch because I had a housemate who moved out. So I've got a lot more space here for the moment. Might have a new housemate at some point, but right now it's just Tuco and I. And, you know, stuff in the world keeps happening, and a lot of that is hard to weather, but it's, I don't know, it's easier when there's a foundation of some sort there with things that you can do that are not terrible. I have those occasionally. I mean, I'm hoping that's what this stream stuff can be a little bit. Like, I'm trying to have some kind of routine for doing stuff and paying the bills. So I don't know if I should be trying to get more work, or if I should be focusing on the videos. And, well, right now I'm streaming. We'll see where that takes me. I'll try to stream again pretty soon. I haven't been doing this on a regular schedule lately, but I do have announcements. You can follow me on Twitch or on YouTube and get those announcements. I also have a bot on Twitter. It's at scanlime-in-progress that broadcasts these announcements. I'm gonna go give this guy some cuddles, maybe make some food. I will see you folks next time. Have a nice day.